Hello, my name is Lilith. This is Nikita here, my coworker, and welcome to Beyond Git, real-time version control for Godot. We are contractors at the research lab Ink and Switch, and for the past little while, we've been developing Backstitch, which is a real-time version control plugin for Godot. And we're proud to have funding from the Endless Access program. Before we get to that, let's talk about Git. What is Git? Why are we doing this in game dev? Why do we use Git? So, Git allows us to check in our code to a repository that handles version control. It allows us to revert to any point in history and merge simultaneous changes from multiple collaborators. And along with Git, we get this wonderful effect called Git hell. Now, I've been to Git hell. Many of you will have been to Git hell. We're going to go to Git hell today. So to enter Git hell, first we need to get repositories. So we type in some arcane nonsense into the console, and eventually we land ourselves into a Godot scene. Here we're editing main.tscn, and we see some nice textures and a flag, and let's say we want to add some coins. So we do that. We add some coins. And let's say we want to share that with our team. So we go back to the terminal, we stage our changes, we commit them with a nice message, and then we push them so that other people can get them from the remote. Except there's a problem. It says, failed to push some refs to the remote. This simply means that someone else has committed and pushed their changes before we could push ours, which is fine. Usually we just need to type git pull and it should automatically merge our changes. Except it doesn't, because we've edited the same file. We've both edited main.tscn, and it says to fix the conflicts and then commit the result, which that's fine, right? We open up Godot to fix some conflicts, then we hit the reload from disk button. Then we get this. Alert, error while parsing file, main.tscn. This means that according to Godot, this scene is now corrupt. We can no longer open it in Godot whatsoever. Now, if you really know what you're doing, you can fall back to a text editor that supports git merge metadata. This is Visual Studio Code, and you can see the different changes that we've made. In this case, there's not that many changes. We just added some nodes. But as you make larger and more complicated changes with resources and assets, this becomes very difficult to merge by hand. But for most people aren't going to know what to do. And if you're on a team, if you're an artist maybe, you're going to go and ask your senior programmer and say, please help me. I screwed up. Please. And they're going to say, oh no, not again. This is the fourth merge conflict I've had to deal with this week. So the reality is that you're often just going to give up instead of spending hours of work merging this stuff. You're just going to do it again from scratch, which sucks. So this is untenable, right? How do dev teams currently handle this problem? So first solution, Git good, right? Just train your artists how to use Git better, which Git is a very technical term, or technical program, and involves using the terminal, and it sucks, and it's very difficult to learn. So what about another solution where everyone works in a separate branch? They still use Git, but they just make sure to commit their changes on the separate branch. So that way they never encounter merge conflicts. And then all of the merge conflicts are now one person's job to merge all by themselves, which is a full-time job in and of itself. So more realistically, what ends up happening is that artists end up banned from Git entirely, and this locks them out of Godot, where we have artists using Photoshop or Krita, we have musicians using their workstations and providing all of these individual asset files to the programmer whose job is to integrate everything, which is also a full-time job, but also it creates a tyranny of the programmer, right? The programmer now controls the art direction for the project. because they're the ones integrating everything, and artists aren't able to have the impact. They're not able to use Godot and see what is possible and impossible and figure out what they want from the art direction. And oftentimes, the game ends up looking like it too. Or maybe if you're a programmer, you view this the opposite way. Maybe there's a tyranny of the artists, right? Maybe there's a bunch of artists constantly hounding you to integrate their changes when you need to be coding mechanics. And even if everyone knows Git, even if everyone is a Git wizard, it's just not made for games. People are human. They're going to forget to pull. They're going to forget to push. And they're going to cause merge conflicts. And even if you just want to work with your friend in a Godot scene, you're now having to play Git tennis, committing and pushing and pulling and committing and pushing and pulling just to see each other's changes. Git sucks for games. It just does. It's made by programmers for programming, but games are a lot more than code. And worst of all, artists feel locked out of Godot because they can't use Git. Now, if you think Git hell is bad, try Git hell for classrooms. Endless Access. It's a program that teaches students game development with Godot. It's a really cool program, and they have this game called Threadbare. That is a collaborative game made by groups of students. And students are able to make their changes come to life and see them in a real-world game that you can go and play right now. And it's versioned using Git. Uh-oh. So if you think teaching a bunch of artists Git is bad, try dealing with a group of 20 students' merge conflicts. It doesn't work. You can't. It's not possible. You need to teach a game development class, not a Git development class. So how does Threadbare handle it? Well, their answer right now is to copy any file the student wants to change. So they have to copy their scene files or their asset files and name them like first name, last name, and then provide them all to the instructor and have the instructor do all the freaking merging, which takes forever. And students expect easy collaboration. They don't like to do this stuff. They're used to stuff like Google Docs, where everything's just easy and instant, and bending over backwards to accommodate bad version control. It feels like busy work. It sucks. And we believe that a better world is possible. We think there need not be any dev team hierarchies, no tyranny of the artist, no tyranny of the programmer, where everyone can work together in Godot and all be friends again. Or in a classroom, there need not be Git nightmares. Everyone can just work together. Introducing Backstitch, which is a real-time version control plugin for Godot. So in this little demo video here, we have two instances of Godot open. And on the left, we have someone named Nerys, and on the right, we have someone named Benjamin. And they're working on whiteboxing a platformer level together. And using Backstitch, you can see our Backstitch sidebar here on the right. This is Benjamin's instance. They're able to sync their changes in real time. So whenever Nerys makes a change in the left, that change is immediately reflected in Benjamin's scene on the right. Now, what's really cool is that this is actually how fast it is. Obviously, these are two clients running on the same machine, but they're hitting a remote server right now. So it still has to do the round trip. And when you see that save, it is immediately synced over. It is fast. So as they're developing this platformer level, we see these changes stacking up where it tracks the changes that each and everyone has made. And in a moment here, Benjamin is going to want to add some art because Benjamin fancies himself an artist. So once they add some coins, some areas for the coins, then Benjamin will be creating a branch. Now, a branch in Backstitch is like a branch in Git. It lets you create a bunch of changes that are separate from another person's set of changes. So Benjamin creates a branch here, names it add some art, and then gets to adding some art. And so Nerys is able to continue editing and whiteboxing the level without seeing any of the incomplete artwork. So, and on this panel here, now that we're in a branch, you can see our changes for the branch stacking up. So it says here that Benjamin's added a bush sprite here to the assets and also an import file for it. And then is also now modifying the scene file to add some bush nodes. And these are just decorative. So Benjamin works for some time adding bushes. Let me get some water, because I'm about to lose my voice. Yep. So Benjamin is, adding some stuff, adding some sprites. Now he is adding some platforms. And he's doing this in kind of a weird way, right? He's just kind of overlapping the sprite with the collider, which is not really how you want to do it in Godot. Normally, you'd create a scene instance, or at least What? Oh, no. Oh, we're back. Awesome. Anyways, normally you'd want to create a scene instance, and then that way all of the data is connected, but he's just overlapping it, which technically works, but it will create a merge conflict in a moment. So yeah, Benjamin has been stacking these sprites here, and and meanwhile, on the left here, Nerys has been continuing to whitebox the level. Now, you may see what's about to happen, because Nerys makes a new platform and then moves this old platform over and then moves the coin. And because Benjamin's just been like overlapping the art assets with the existing collider platforms, that's not going to merge together quite well, right? So, but none the wiser, Nerys makes some level changes here. And then Benjamin, on the right here, decides everything looks good and hits the merge button. This sends us into a merge preview state where we get this useful little warning message that says main has changed since the branch was created, that you should be careful and merge and review your changes before merging, which Benjamin does. So Benjamin looks at all the various changes, makes sure everything looks okay, and then zooms out and notices that, okay, Nerys has made some edits to the colliders, so the textures no longer line up. But that's fine. That's something that's fixable. So Benjamin is in this merge preview state, able to simply move the platform over and make another platform, and then move the coin over. And so that way, everything looks fine, and Benjamin is cleared to merge. Water time. All right, back in Nerys' side, Nerys has decided to change the color of one of the coins, and she can see that change here in this panel here, where you can see the changed properties before and after. And she decides to revert that change. She goes into the revert preview mode, and then can accept that revert preview to then revert. And revert is useful for previewing a point in history as well. So in this case, Nerys wants to see what it looks like without art. And so she hits the reset button and then can confirm that to remove all of Benjamin's changes. Oh no, but it's okay because you can just revert a revert and all the art's back and everything's fine. So that's the Backstitch demo. That was a lot of information, so let's go in detail into the features. So this is the Backstitch sidebar. It's got fancy buttons up top for syncing and stuff. It's got a branch picker. It's got the history where you can see everyone's changes. It's got this change panel where you can inspect the specific change. And for feature branches, you can click the branch button to make a branch. And then once you're ready to merge it, you can hit the merge button and go into a merge preview state where you can make sure everything looks okay. And you can then revert to any point in history by hitting the revert button. We also have visual diffs, where if you mouse over a specific change, it will highlight the location of that change in scene, which is pretty cool. So that's the features of Backstitch. Let's talk a little bit about how Backstitch handles conflict resolution. So real-time sync is the best part about how Backstitch works, right? And this means with immediate syncs, it means that you have smaller and less frequent conflicts when you're handling merges. So when someone changes something and another person changes something at the same time, it's able to kind of just pick one, and that usually looks okay because it's so immediate, because every single change that you save is immediately synced. But of course, there still are going to be conflicts, right? There's always going to be conflicts. So let's talk about how Git handles it versus Google Docs versus Backstitch. So Git is pretty good at code resolution, and it lets you know when you need a manual merge. Google Docs is really good at specifically and only rich text conflict resolution. And it's so good that it's completely automatic, and you usually don't notice any conflicts happen. And Backstitch has to exist in kind of a in-between state, right? Where conflict resolution is automatic, but it can be inspected for errors. This allows us to have things like branches and merging those branches, and you can see that merge preview state as the interface where we allow users to inspect for errors. And to do all this, Backstitch uses AutoMerge, which is a really cool automatic merging version control library made by some people at Ink and Switch and maintained by them. It's an open source community project, and it allows us to parse the scene into structured data instead of text, where it allows us to merge conflicting scenes together automatically. And we maintain this really important invariant where no matter what was in either scene, the resulting scene is always going to be valid. We're never going to have a corrupt scene that Godot is unable to open. So no matter what, even if something looks kind of wrong, like we saw in the demo, you can always just go into Godot and fix it yourself. And there's an important question here that some of you may be asking, which is, all of our stuff is in Git. We use Git already. I don't want to use a new thing. And the answer is, you can keep using Git, actually. I know I just said how Git is awful, but it's got really mature cloud platforms like GitHub and Bitbucket. And a lot of people use it already for distributing their code. And that's fine. So what Backstitch does is it can go on top of each person's repository. So let's look at how that would work in a game jam setting. So you would set up a Godot project like normal and check it into Git, and you would upload it to GitHub like usual, and you would install the Backstitch launcher into the project. And collaborators can now join a Backstitch project by running the launcher. And this allows everyone to keep their instances of the repository in sync, and then maybe one person, once a day, will commit their changes to Git and commit everyone's changes to Git all at once. And maybe that'll be the person who knows a little bit more about how Git works. So what have we learned? Git hell sucks. You should use Backstitch. It's got live sync on save editing. It's got branch merge and revert. It's got intelligent conflict resolution, and it works with your existing version control. It's great for game jams. It's great for classrooms. How do we get started? You can visit our website, backstitch.dev, and we have a tutorial and some docs. For now, here, I'm going to not stand in front of the QR code. There we go. And for now, you'll add our launcher to your project and double-click to run. And starting in Godot 4.7 will be available in the asset library. We need your help. Backstitch is alpha software. This means there will be bugs. There will be many bugs. There will also be workflow issues that we haven't predicted. So we need your feedback so that we know how to make it better. This is the call to action. We want you to go to our website if you're interested in Backstitch. Hit the Getting Started button, and then fill out our form with your contact information. This will allow us to contact you directly about your use case. This will allow us to, connect with you, get your feedback, and if something doesn't work for you, then we can fix it instead of it just going into the void and all that feedback disappearing. So do that if you're interested in using Backstitch. It's right there. Take a picture. Okay, that's the talk. Any questions?
Oh my God. All right, I'm going to start here, and then we're going to go and try to get.
Hi, great talk. It looks really interesting. I was just wondering is it possible to use Backstitch for a portion of the repo? Say, if an artist doesn't need to care about the writing files, then or the writer doesn't want to care about the art files, but they both want to care about the scene files, would it be possible to use Backstitch just for, say, a subfolder that's all of the scene files in the project?
That is a great question. So we support git ignore syntax in a Backstitch ignore file. So you could easily add anything you want ignored to the Backstitch ignore file, and then yeah, you can exclude that stuff from the version control Backstitch and just fall back on Git maybe for that.
Hi. So just to understand it, every time you like save a scene or save a script, it will automatically commit the file to the Git history?
It will not commit into the Git history. It will commit into the Backstitch history, which is separate. So Backstitch uses auto merge as a backend. Git uses a Git index as the backend.
So there would be no concern about like finding the exact history you want to go back to. And if it ever becomes too big, because I assume after like thousands of saves, you probably run into storage issues.
Yes. We currently, so in terms of the server, we currently run an alpha test server. It's one of those situations where you can also easily run your own server. That said, AutoMerge is pretty good about not exploding in giant data storage, just like Git is pretty good at that. So we haven't run into any issues like that, thankfully.
Okay, thank you.
We've tested this with over 100,000 changes on a single project. It still ran fine, so.
But also, it's your job to break it.
Hello, great stuff. I'm just wondering, how does it resolve conflicts for binary files, and whether it does it at all?
That's a good question. So currently it just picks one. You can inspect something like, let's say, an image file. It will give you a little preview of like the before image and the after image and what happened. But yeah, there's no current like built-in special merge functionality for arbitrary binary files.
So like a user have to choose the file, the final file?
Basically, yes. It'll automatically pick one, and then if the user doesn't like that result, they can go and change it.
Thanks.
Amazing, by the way. But Backstitch is not a Git client.
It is not a Git client.
Right.
Correct.
So the way you would probably set this up, like in a team with one developer and the rest artists, is the developer maintains a Git, but everyone in the project uses Backstitch, and the developer just at the end of the day merges and...
Yep, yeah. Exactly. Where the artists up here, they use Backstitch. They don't worry about committing to Git. Maybe they cloned the Git repository when they were setting something up, but after that, they haven't had to touch Git because all of those sync, and then once a day, the programmer will just Git commit all of the changes from the day.
So is there a reason to use Git? I imagine for like rolling back versions in
yes, that's a version. Another reason to use Git is that we are an alpha. So, you know, versioning your stuff using Git, it's probably a pretty good idea just in case.
Sure.
And also it's good to have cloud tooling like GitHub and Bitbucket that we as a very small dev team cannot provide for you.
Yeah, makes sense. All right.
It looks really cool. In case a developer is adding a new property to a node, like a new export property something, how does that get handled if they have a node available locally, which other clients don't yet have because they've not gotten the code in back yet?
So it will show. So if they add a new node, it will show as an added node.
I mean more like a code node, as in a new value on a node that you can just change in the editor.
So you mean like within a scene, or?
Yeah, like a speed variable or something like that.
Yeah, okay. So scenes are sort of, whenever you save a scene, it hits the file system. That scene is parsed into Backstitch. So whole scenes are synced at once, and then we can diff that with other copies of the scene. Does that answer?
And if the other clients don't have the code yet with those variables, that won't conflict?
If the other clients don't have that code yet, then there's going to be a split second where they don't have that code, but then everything else is going to sync at once. So like, let's say you add something to a script, and then you also modify the scene. Because you're immediately syncing, then that script file is going to sync and that scene file is going to sync. So both of those sync together, so everything lines up okay.
Okay, cool.
Hey, thank you. This looks pretty dope. But I have a question about the backend. The thing with Git is that you can set up your server and do continuous integration and all these nice things. What's the Backstitch backend? Can I just install it on my VPS or how?
Yes, you absolutely can. We have a server. I would recommend running it behind a VPN just because we haven't tested it for security. But it works great. You can install it with a command. You run it in the command line like any other server. And then auto-merge is also open source. So if you want your own fancy server with fancy authentication or other stuff, then if you got the ability and the knowledge to do so, you can absolutely customize the default server that we provide.
Cool stuff. Thanks.
Great talk. How does it handle really large files?
That's a great question. Really large files is something that we are going to have to look at in the coming months. If we're talking I can't remember what our current file size limit is, but we do have a current file size limit in the gigabytes. And yeah, that's just a very difficult problem to solve in version control and one of the biggest issues with Git. But it is on our radar and we will be looking into it in the coming months.
Cool, thank you.
Thank you for the talk. If I understand correctly, AutoMerge uses CRDTs, correct?
Correct. Very smart.
Then why do we need a server at all? Isn't it P2P, or is the server just acting as a router?
Servers acting as a router, yeah. We don't currently support peer-to-peer. There's no reason we couldn't support peer-to-peer in the future. It's just something that comes with a lot of gotchas and a lot more difficulty to diagnose sync issues if we don't have things piping through the server as a router. Okay. But that's a really good point.
Thank you.
This looks absolutely amazing. I think maybe your primary user test subjects are children in a classroom.
Yes.
Have you done user testing for small or medium-sized companies?
We have not. That's your job. Fill out our form on the website. We want to connect with you, run some tests with real small game teams. We want people running game jams with this in particular, just to see low stakes, how it works, how they like it. Yeah, use it for your next game jam. Contact us. We'll help you. Please.
Yeah, I'm excited to bring the good word back to Portland, Oregon. So
yes, please, please, please do.
All right, I believe 3-4 more questions.
Thank you. Really amazing talk. I have one question. Are you planning also to integrate the CLI front end? Might be interesting for pipelines.
That's a great idea. That's something I have in my personal wish list. So at some point, yes, maybe not in the next immediate future, but at some point, absolutely, I would love to do that.
Pricing?
Sorry, say that again?
Pricing? Are you planning to charge for it?
It's free, open source. You can go look up the code on our GitHub. We have no current plans to charge for any of this.
Amazing.
But you may have to run your own server.
So first of all, I want to say this is absolutely amazing, and I've wanted something like this without knowing that I wanted it. What other thing regarding the server? Are you providing a Docker image?
We don't currently have a Docker image, but I think it would be very trivial to set one up. We could do that, yeah. I would say open a GitHub issue on the server repository, and I would be more than happy to set one up for you.
That's great, thank you. The other thing is, like, just generally how I can see how this was created out of pure frustration about Git, and I don't know, it makes me kind of laugh. Thank you for creating this. Thank you for making a talk about it.
Yeah, of course.
Yeah, I also share. It's fantastic. But is there maybe in the future some plan to have really like something really like Google Docs where I don't need to save to even see the?
I would love that personally. The problem there is that we would have to integrate much more aggressively with Godot as an engine. There were some early experiments doing that, but it would lead to a lot of segmentation faults, a lot of issues. This is something that I want to look into in the future more. But for our alpha and probably beta versions, we will probably not have like true real-time keystroke editing, although it is something I would personally absolutely adore.
Hi, yeah, this looks incredible, I agree, and I can really see it becoming kind of a Godot staple, potentially. But so related to the pricing question from earlier, I'd be really interested in like how big your team is, if you're working on this full-time, and importantly, who's financing it, because that's kind of informs, future development and maintaining.
That's a great question. So currently, the full-time devs on this are me and Nikita. And we're working for an independent lab called Ink and Switch, who was basically hired by the Endless Access Program and the Endless Foundation, who were like, we need this for our classrooms. This is a terrible time for all of our instructors. We need a better solution than Git. So they gave Ink and Switch a bunch of money. Ink and Switch hired me and Nikita to come work on this, and we currently work on this full time. And yep, that's the money.
Thank you.
All right, I think one more question and then we'll go to the next talk.
Hi. So when you showed like the video, my mind went immediately to, I guess you can be really annoying with this.
Yes.
So I was wondering, like, for example, if your programmer is programming some mistakes that prevent the game from like launching preview, will that adapt to the others as well? And I guess there's probably some form of discipline that the team needs to upkeep, I guess?
There is, yeah. So what we would recommend for that is to create feature branches for anything that could potentially mess up. So you make a branch, and then that keeps your code nice and separated so that you can make in-progress stuff that's going to break everything. And then only once you're sure that it's not going to break anything, then you merge that back to the main branch, and that syncs to everyone else. But of course, there's nothing stopping you from breaking something on main and propagating that to everyone. So be a little bit careful, baby.
All right. Thank you all so much for asking questions. Thank you for the presentation.
Thank you all.
Go to the next one.